Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, we are from Group 7, Section 10. In this video, we will discuss about LOCUS, or Tempat Kedudukan. The members of Group 7 are Elsya, Insani, Saheri, Jovita Ardelia, and Nabilah, Adriana, Putri. So, let's get started.
So, the first material is about the concept of locus. Definition. A locus is the set of points in a coordinate plane that satisfy the following condition. The first one, all member points of the set have the same properties. The second, all points that have the property are members of the set. Locus helps determine the shape or position of an object based on certain conditions while clarifying the relationship between mathematical equations and geometrical forms. So, we can conclude that locus is the set of all those points whose location satisfies by one or more specific conditions. Okay, for example, please take a look at the following video. The locus of point P, which is at a fixed distance from a fixed line. And the locus of point P is a circle. And then locus of a point P, which is at a fixed distance from a fixed line. This is, so the locus of point P is line. And then locus of a point P, which is equidistant from two fixed points. And the locus of point P is a line. And then locus of point P, which is equidistant from a line and a fixed point. This is the line and this is the fixed point. The locus of point P is parabola. And then locus of point P is such that PS plus PS accent equals K. And locus of point P we can see over here is ellipse. And then locus of point P that PS minus PS accent equals K. And the locus of point P is hyperbola. This is another type of locus of point P that make a hyperbola. So, the next material is about interpretation of locus. Geometric interpretation of locus. Locus can be understood geometrically as a set of points forming a specific shape in a coordinate plane. The steps to determine the position of a point are as follows. The first one, draw the known geometry object of the locus problem. The second, determine some points that fulfill the properties of the locus. Third, connect the points in the step 2 until we realize the shape of the given sheet. Fourth, describe the set of points that are members of the locus and describe them with words. This is the example, the locus point P that equidistant from a fixed point S and a diacritic line G that makes a parabola. Another example, the problem is determine the locus of points that are equidistant from point A minus 2, minus 4 and point B minus 5, 2. So the solution is, the first one, we should illustrate point A and point B. This is the point A, and over here is the point B. And then the second, determine some points that satisfy the locus property. We can define the midpoint AB. This is the midpoint. You can use algebra equation, and we can define the midpoint AB as one of the points on the locus. So, midpoint AB, such as point T1, is the one of the point on the locus. Then determine the other points that are equidistant to A and B. Then we can get this locus. So the locus of 2 points is a line. Number 3, locus is a straight line through the midpoint and perpendicular to AB. So locus is straight line. This is the straight line through the midpoint. This is the midpoint T1. This is the midpoint of AB and perpendicular to AB. So we can conclude the locus is a straight line through the midpoint and perpendicular to AB. Okay. The next interpretation is algebraic interpretation of locus. Locus can be represented algebraically using equations that describe the set of points satisfying a given condition. For example, look at this picture. The locus of points that equidistant from a fixed point, this is the fixed point, 0, 0, and the radius is 2. We know the equation is x squared plus y squared equals 4.
Next material is about methods to solve problems about locus. There are 3 methods that we can use. Let's begin with method A, operating the point. This method has several steps that we can follow. First, we need to choose any point or random point that meets the specified condition. Here, let the point be x0, y0. Then, we should determine the relationship between x0 and y0, where this relationship must be consistent for every value of x and y in the locus. And last, we need to process the point by removing the indicator to get the general locus. Let's take a look to the example. Determine the locus of points that are equidistant from point P 4, 3 and key 2, 1. First, we need to choose any point. In this case, let's choose point T, xt, yt. Dear friends, you can see the graph on the side to see the position of the points given. Since point T should satisfy the conditions, the point T is equidistant from point P and key, so that we had pt equal to t or distance relationship. Then we use algebraic forms to find the relationship. Especially, we're using the distance formula. pt equal to t, where pt is the roots of xp minus xt all square plus yp minus yt all square equal to p, where p is the roots of xk minus xt all square plus yk minus yt all square. Then we substitute the given value to the equation and we squaring both sides to eliminate the square roots. So we get 4 minus xt all square plus 3 minus yt all square equal to 2 minus xt all square plus 1 minus yt all square. Then just do the algebra till we get negative 4xt minus 4yt plus 20 equal to 0. Then we divide them with negative 4. So we get xt plus yt minus 5 equal to 0. Now, we need to simplify them by eliminate the specific indicators and obtain the general equation for the locus. We just need to take out the t there. Thus, the locus of points satisfying this equation represents all points that are equidistant from P 4, 3 and key 2, 1 is x plus y minus 5 equal to 0 or x plus y equal to 5. As we can see in the graph on the side, the locus is a straight line. Next is method B, using the parameter. If you need to use this method, you can follow the several steps. First, choose a parameter, where the parameter is the determinant of the equation. Then, we need to find the relationship between variables and the parameter. And last but not least, we should eliminate the parameter from the equation. My dear friends, here we got a problem to determine the locus of point P x, y so that the measure of angle APB equal to 90 degree. Where point A, negative a, 0 and B, a, 0 are given, such as the graph on the side. First of all, choose a parameter. The parameter usually related to slope or gradient, distance or angle constraint. Let's find the slope of AP, where coordinate of A is negative a, 0 and P is x, y. Slope of AP equal to y minus 0 all over x plus a equal to y over x plus a. So the slope of AP is y over x plus a. The next is we need to identify relationship between variables and the parameter. Since AP perpendicular to PB, so the slope of AP times the slope of PB equal to negative 1, where if we find the slope of PB with the same way with AP slope, we get the slope of PB equal to y over x minus a. Then we substitute the value of AP slope and PB slope equal to negative 1. It is y over x plus a times y over x minus a equal to negative 1. Then we get y squared over in bracket x plus a times in bracket x minus a equal to negative 1. Then we multiply both sides by in bracket x plus a times in bracket x minus a. So we get y squared equal to negative of in bracket x plus a times in bracket x minus a. Then we solve the equation to eliminate the parameter and obtain a final equation in terms of x and y only. We already got y squared equal to negative of in bracket x plus a times in bracket x minus a. Then we simplify them to get y squared equal a squared minus x squared. Then we add x squared to the both sides. So we get x squared plus y squared equal to a squared. And this equation is familiar, right? Because the equation represents the locus as a circle centered at 0, 0 with radius a.
Method C. Combination of method A and B. The problem can be solved by method A first or B first, so there's no general steps. Example, determine the locus of center points of a chord that parallel to line y equals ax if circles x squared plus y squared equals a squared is given. Solution. First, do a little analysis. Given the equation of the circle x squared plus y squared equals a squared. The chords are parallel to line y equals ax. Since the chords are parallel, their slope must be the same. Their equation can be expressed as y equals ax plus n. So we already got the equation of the chords are y equals ax plus n, where n is a parameter that shifts the chords vertically. 2. Substitute y equals ax plus n to the equation of the circles x squared plus y squared equals a squared. So we substitute and we got x squared plus ax plus n in bracket square equals a squared. X squared plus a squared x squared plus 2anx plus n squared equals a squared. And we got 1 plus a squared in bracket x squared plus 2anx plus n squared negative a squared in bracket equals 0. By using ABC formulas, we're gonna get two roots from the equation x1, x2. Let t, xt, yt be the center point of the chords using the sum of roots formula. So x1 plus x2 equals negative 2an divided by 1 plus a squared. Then we're gonna get the midpoint of the chords as xt equals x1 plus x2 divided by 2 equals negative an divided by 1 plus s squared. So we got n equals negative xt times 1 plus a2 divided by a. For we substitute the value of n to yt equals axt plus n. Yt equals axt plus negative xt times 1 plus a squared divided by a in bracket. We do algebra and we got yt equals negative xt divided by a. 5. By simplifying, we eliminate the dependence on specific indicators and obtain the general equation for the locus. Thus, the locus of points that represents all midpoints of the chords at circles x squared plus y squared equals a squared is y equals negative x divided a. Steps to determine the types of locus if quadratic equation is given. First, identify the form of the equation. Second, simplify or change the form into the general equation. General equation like circle, parabola, ellipse, and hyperbola. Third, analyze its property based on the standard form. And the last, draw the graph to verify the shape of the locus. Example question: determine the locus of points whose distance from the point negative 4, 0 is equal to their distance from the y-axis. From the question is given a locus of points that have equal distance to point minus 4, 0 and to y-axis. Solution: first, choose any points. In this case, let's choose point P. So, xp and yp. Number 2, relationship between the points. Since point P is equidistant from points negative 4, 0 and y-axis, we have PA equals PB, distance relationship. Next, find the relationship using algebraic forms. PA equals PB. We use distance formula. Roots of xp plus 4 in bracket square plus yp minus 0 in bracket square equals roots of xp minus 0 in bracket square. We eliminate the root and simplify and we got y square p plus 8xp plus 16 equals 0. So the relationship between the point is y square p plus xp plus 16 equals 0. 3. By simplifying, we eliminate the dependence on specific indicators and obtain the general equation for the locus. Thus, the locus of points satisfying this equation represents all points that are equidistant from point negative 4, 0 and y-axis is y squared plus xx plus 16 equals 0. So that's all the material from Group 7 Section 10. Thank you for your attention. We apologize for the mistakes. Thank you guys. Wassalamualaikum warahmatullahi wabarakatuh.